Without radar vectoring, an instrument procedure relies on pilot self-positioning at the initial approach fix, IAF, and then flying a published aerodrome procedure. This may be done using a facility on the aerodrome that serves both as the IAF and the MAPT. Some form of track reversal procedure is required, in which the aircraft is flown outbound from the facility on a defined track, and then turned to fly inbound back towards the facility. A simple procedure should provide for an outbound track from the fixed facility, followed by a track reversal inbound back towards the runway. This is called a procedure turn or base turn. The standard procedure for track reversal is the procedure turn, and is defined as a turn from outbound to inbound in which flown tracks are reciprocals. It has two variations, which we will show you. The 45-degree or 180-degree procedure turn is the first variation, and requires track guidance to a point, timed or DME, where a 45-degree turn is made, followed by a straight leg of either 1 minute for Category A or B aircraft, or 1 minute 15 seconds for Category C, D and E aircraft. At the end of the timed leg, a Rate 1 turn is made through 180 degrees to bring the aircraft into a position to intercept the reciprocal of the outbound track at an angle of 45 degrees. The 80-degree or 260-degree procedure turn requires track guidance to a point using time or DME as a reference, where an 80-degree Rate 1 turn is made, followed immediately by an opposite direction 260-degree Rate 1 turn. In still air, the procedure should take exactly 2 minutes. A published procedure turn illustrated on an approach plate would look like this. An alternative to this is the base turn procedure, which is usually associated with a VOR beacon. A base turn can be specified where the inbound track is not the reciprocal of the outbound track. The specified outbound track is followed to a predetermined point at which a Rate 1 turn is made, so that the aircraft rolls out onto the required inbound track. In order to obtain an accurate outbound track, the procedure is defined to allow an aircraft to maneuver at the IAF prior to commencing an instrument procedure. You will soon discover that the racetrack pattern, which consists of a turn from the inbound track through 180 degrees at the facility or fix, after which an outbound leg is flown to a point defined by time, or at a fix at which another 180-degree turn is made to bring the aircraft back onto the inbound track to the aerodrome. It is used where aircraft are required to enter a holding pattern prior to commencing the instrument procedure, and where the orientation of the holding pattern does not permit either a procedure turn or a base turn to be used. It will normally be specified as an alternate procedure, and specific instructions will be on the plate. Racetrack procedures are usually used where sufficient distance is not available in a straight segment to accommodate the required loss of altitude, and when entry into a reversal procedure is not practical. In these cases, the particular pattern one flies is prescribed, to ensure that the aeroplane remains within the designated airspace. The pilot must strictly adhere to the directions and timings. The following specifies the procedures to be adopted when flying racetracks and reversals. Entry. Unless specified otherwise, procedures will be entered from a track within plus or minus 30 degrees of the outbound track of the reversal procedure. For base turns where the plus or minus 30 degrees direct entry sector does not include the reciprocal of the inbound track, the entry sector is expanded to include it. Speed restrictions. These may be specified in addition to or instead of aircraft category restrictions. These speeds must not be exceeded to ensure the aeroplane stays within the designated area. Bank angle. Procedures are based upon a bank angle of 25 degrees, or the bank angle giving a rate of turn of 3 degrees per second, a Rate 1 turn, whichever is less. Descent. The aeroplane is to cross the fix or facility and fly outbound on the specified track, descending as necessary to the specified altitude. All further descents should only be made when established on the inbound track. For reasons of safety, all turns are level turns. Outbound timing racetrack procedure. When based upon a facility, the timing starts when abeam the facility, or when attaining the outbound heading, whichever is later. When based upon a fix, timing starts from attaining the outbound heading. The turn onto the inbound track should be started within the specified time adjusted for wind, or when encountering any DME distance or radial bearings specifying a limiting distance, whichever is first. Wind effect. Due allowances should be made in both headings and timings to compensate for the effects of wind to regain the inbound track as accurately and expeditiously as possible, and therefore achieve a stabilized approach. DME distances should not, however, be exceeded when flying the outbound track. RNAV procedures, based on VOR DME co-located facilities, are non-precision procedures and are increasingly being used. Aircraft equipped with approved RNAV systems may use these systems to carry out VOR DME RNAV approaches, providing that before flight it is ensured that the RNAV equipment is serviceable, the pilot has current knowledge of how to operate the equipment and achieve optimum levels of accuracy, the published VOR DME facility upon which the procedure is based is serviceable, the input data is up to date. RNAV systems are now able to project a vertical path angle, VPA, to create the so-called Approach Procedure with Vertical Guidance, APV. This effectively turns a non-precision approach into a kind of precision approach. The procedure does not meet the precision approach criteria and is a hybrid. However, it has a glide path and does replace the minimum descent altitude or height of the non-precision approach with the decision altitude or height of a precision approach. PAN-OPS suggests decision heights of 250 to 300 feet, depending on the aeroplane type, accuracy of the RNAV equipment, etc. Another term associated with this type of procedure is Baro VNAV, which is, of course, vertical navigation of the RNAV system, using the pressure altimeter. You must not forget that there are several factors that affect the accuracy of RNAV systems. To remind you, these are ground station tolerance, airborne receiving equipment tolerance, flight technical tolerance, system computational tolerance, and distance from the reference tolerance.